And so if this emotionally hurts you, um, we'll figure out how to get therapy. Let me go ahead and share screen. So hopefully, yeah, hopefully all of you are having a good Halloween. So I'm living in one of those neighborhoods where a couple of neighbors go, I mean, pretty much all out. And what's kind of cool is when my kids were really young, we used to go taking trick or treating. There were a couple houses where people who work on Hollywood sets would have some leftover things from movies that they built or whatever it was. And so there were some pretty amazing setups, which are kind of cool. So it's always fun to just walk around and see what people have. And that said, let me go ahead and hopefully, oh cool, it did recognize this. Okay, let me show you what's loaded up. I'm going to, okay, so this is interesting. Spent a ton of time personalizing the questions that this guy submitted. So the first three, I'm just going to move, not here right now, it's going to move those to the end. I'm going to rotate up different ones then. So it was going to be a heavy OChem day. It just became a heavier GChem day. So let me rotate these into the higher up in the list then. Okay, so still going to start with OChem. So yep, you're here. So 1, 2, 3, 4, 5, 6, 7. A lot of 8 chirality questions. Those other ones were also chirality. So, and then oh, okay. So the person who submitted these two also not here. So this one and this one, I'm going to also rotate to the very end of today. And so I need to switch books for just a second. Okay, so if you have your OChem book 1 and your GChem book 2, those are the two we're going to hit up early on. So I'll go ahead and get started on this. I don't know what, there we go. Hopefully this will click in. Just a second, might have the wrong iPen. Okay. Oh, okay, hold on. It's doing this to me. Sorry, it's finding a different device that isn't even turned on. So I sincerely apologize. I just need to turn off another computer. Okay, actually, good on this one. Okay, finally. I am so sorry that it's just, I basically have 4 things loaded to the same iPad and for whatever reason it jumps whatever, but okay. For this one, which one carry a positive charge? Well, first and foremost, what happens if you add a strong acid? How does the molecule take on a positive charge? Let's first consider like how you get a positive charge. So if I add a strong acid, can you protonate an organic molecule? Is that possible to add an H plus somewhere on a molecule? Okay, where? Through resonance, you can resonance stabilize it. So tell me where the easiest spots to add an H plus, to the middle of the molecule or terminal end? Central part or terminal end? Terminal end. So typically we add to the end because less sterically hindered, and we generate a more stable carbocation. So this could go here. So it could add to that double bond, which would leave me with this part of the molecule still intact. This becomes CH3, CH3, and a carbocation. So would you agree we could get plus charge on E? So yes and yes. How many are okay with that? That's fine. We could protonate there. Okay, so let's see where else we can get it then. So we're going to have to protonate somewhere else, but for this one, this can't really resonate to anywhere else. There's no pi bonds around it. But we could also potentially protonate one other spot. In fact, the more likely spot to protonate, would it be protonating on carbon C, carbon B, carbon A, or oxygen, the one carrying the delta minus? Not that I'm trying to bias you, but this one, this one, this one, or this delta minus oxygen. Perfect. So definitely it's going to be able to put a plus charge on A, whether it can do on B or C. Good point. So based on what's left, can resonance put positive charge on neighboring carbons, or is it every other carbon? Every other. So we could potentially get OH, double bond, and a plus charge there with so C and A based on what's left. So perfect. Best answer then choice B. So does that make sense? It's actually kind of tricky in the sense that you have to figure out all the spots you can protonate and then figure out what resonance will do. Once you protonate here, no resonance, but a tertiary carbocation isn't bad. When you protonate on the O, you could put the plus charge on A, or they can swing over and put it on C. But charges go every other when you resonate around a pi system. So hopefully, does this one seem okay? Yep, basic, because of every other. Perfect. And good call. Because wait a minute, weren't you the one who said every other? And now you're asking if every other is true? Where is that confidence? Where is that I take charge spirit? But yeah, exactly. Yeah, see, these somewhat weird or like emojis. What does greater than colon D mean? What the heck? Remember, you're dealing with somebody old who doesn't understand cool computer lingo. I just recently learned that LOL means leaving on the left side. So, okay. So number 11, if you wanted to monitor reaction, then we have to know how things change. So if I focus on this, I'm losing that bond, would you agree? And I'm gaining that bond. My chiral center is inverting because it's an SN2. Or I should say, because it shows backside attack, it's inverting, which happens to be an SN2. So it's either going to be the disappearance of this bond or the appearance of this bond that's going to be what I monitor. So this is going to rely on a lot of memorization from before, but first and foremost, what does an IR peak around 1700 tell me, if you recall? One of the few IR signals you have to memorize. Perfect. You got it right. So carbonyl. Is there any carbonyl involved in this reaction? No, so that one's out. Okay, a change in the ppm value for a 3H doublet. Well, first off, I have no idea what a 3H doublet means. So does the 3H tell me that it is next to a CH3 or it is a CH3? tells me it is a CH3. So a CH3 and a CH3, and what does a doublet mean? Doublet means it's next to, if you remember, the doublet means next to 1H, because your shape is neighbors plus 1. So we can read what I've written, but the shape of a signal is neighbors plus 1. So if you're next to nothing, you're a singlet. If you're next to 1H, you're a doublet. Next to 2 equivalent H's, you're a triplet. Next to 4, you're a quartet. Does that sound familiar? And it's one of those things that it's probably long since forgotten, but does it familiar once you hear it? So it is a CH3, so it's got to be this one, as opposed to this one, because this one is next to 2 H's, so this one would be a triplet, this one would be a doublet. So we're looking at this CH3 right here. Okay, would the ppm value change? Is it next to a different group, and therefore is it going to experience a different signal of some sort? Okay, I'm going to put a question mark because I don't know. I'm not sure if I fully am believing right now. I'm going to leave a question mark. A change in the overall index of refraction. What the heck is the index of refraction? It has to do with the change in the medium, definitely true. So what it specifically has to do with is how, oh shoot, I'm sorry, you're losing me for a second because I'm trying to let somebody into the room. Oh, dang it. Okay, he left when he couldn't get in. If somebody in Discord is asking about getting in, tell them I was really trying to move my cursor, but they gave up on me before I could click them in. So anyway, so index of refraction has to do with physics, if that sounds somewhat familiar. So it has to do with speed of light. So what happens when you go from, let's say, gas to solid? Speed of light increases or decreases based on your physics knowledge? Decreases, perfect. The index of refraction is a measure of what you'd have to multiply that speed by to make it equal to the speed of light in a vacuum again. So if it drops to half of its speed in a vacuum, multiply it by 2. If it dropped to, let's say, from vacuum to air, it barely drops at all, you know, multiply it by like 1.01, 1.02, something like that. But the index of refraction, there's no way we would monitor it. That's a physics thing. So can I get rid of that one because it's physics? And then finally, a UV peak at 242. This is what I'm uncertain of. And it is a totally true statement, but did they tell you that in the passage? Because if they didn't, that's just downright mean of me. I'm trying to look back on this, and to the best of my understanding, nowhere. Oh man, does it? Yeah, I don't see it anywhere. I'm trying to fish through the passage. That is just, unfortunately, just a massive amount of trivia. So all you can really do is, yeah. So it's this is a mean question on my part, and I want to apologize. That said, one thing that is true is UV can measure pi bonds and then carbon to like heteroatoms and nitrogen, sulfur, carbon, so forth. And what it measures is the excitement of a lone pair moving up to an excited state, like a non-bonding site. What, I mean, not you need to know that exactly, but anytime you have an atom with lone pairs, it's going to be involved in some sort of UV. It works out this way. And so a lot of times we use UV vis to measure the concentration. It's kind of a good scrape your knee question. I think so. So I know for sure C and A are out. B, I don't know how much it would change because it's still pretty much on the same thing. And without knowing the exact group, I mean, it might change a little bit. So B or D, getting down to those two. And I know UV is good for monitoring anything except for carbon-carbon single bonds and carbon-H bonds. And then the one thing I do want to just bring up, just to reiterate something from GChem. Do you remember absorbance equals some molar absorptivity constant or an extinction coefficient if you're doing biochem? ECL? Does that sound somewhat familiar? So is Beer's law, is that equation familiar to you? Critical in that this spectroscopy is really important for recognizing formation of products or loss of reactants. As the concentration goes down, the absorbance of light for that signal will drop, or as this compound forms, the absorbance of light will increase because of that. So can you monitor the absorbance at a given wavelength, measured by E, to know the concentration of whatever you're losing or whatever you're gaining? So it's deteriorating. So over time, I would see the absorbance diminish, something like that. So does that seem okay that that's what you'd be looking at, the disappearance of a peak over time? So once we know D is the right answer, how we would do it. So hopefully that seems somewhat familiar. And so the rate of decay represents the decrease in the rate of the reaction. Okay, onward we march. Which of the following is most likely or the most stable leaving group? This is a little bit tricky. So I will confess this is a trick question right now, but let's consider every one of these as a potential leaving group. So what does your gut instinct tell you in terms of which is a better leaving group, something neutral or something protonated? And a good reference, perfect. So the perfect reference is how many learned that if you protonate water, you make it a good leaving group, make it a better leaving group. Okay, so I'm going to tell you then C is worse than D and B is worse than A. But why is A also not my right answer? What is screwy and weird about A? Five bonds. So that actually can't be a leaving group. So a trick question in that sense. So the best answer, the positive one, but you can have expanded octet for sulfur. So that's my best leaving group. Oh no, it is protonated. So if this is your leaving group, so what I've basically done is I've taken this entire group, sulfur with the ethyl and the H, sulfur with the ethyl and the H, and added it to an R. Then I've taken sulfur with just negative and the ethyl and added it to the R. And so that's where that positive is coming from. So the two negative ones when added to the R become neutral. The two neutral ones when added to the R become positive. Okay, so good on this one. Onward we migrate then. We're flowing through. And then we come to this. This is the enantiomeric excess stuff becomes kind of a butt kicker. So I want to figure out what the heck does enantiomeric excess mean? So let's start with the word racemic. What does racemic mean? "50-50." So what is optical rotation? So let's just say, and I'm just tossing this arbitrarily, let's say R is positive, S is negative. Let's just say that that's what they rotate like. So if it's racemic, what's the alpha D? What's a net rotation? 0 degrees, exactly, because half of it rotates it clockwise, half rotates it counterclockwise, they cancel. Okay, what does it mean if I have a positive 20% EE? Positive 20% enantiomeric excess means it's racemic, or does it mean I favor one over the other? Favor R in this case. Why R? You're absolutely right, Stephanie. Why are you saying it's favoring R specifically? Positive 20 as opposed to negative 20 for the other one. Perfect, exactly. So that would mean this is a 60-40. Okay, I want to do this intuitively first, and we'll do hardcore math in a second, but intuitively speaking, 50 cancels 50, so it's 0. Can I say of this 60, if I tell you 40% is getting canceled by this 40%, and there is an excess of 20% that's not being canceled, does that make sense? That's where the number comes from. 40 is canceling 40 of this and leaving an excess of 20 that is uncanceled. So do you get the full rotation, or do you only get 20% of the rotation? Only 20%. So let's say, and I'm going to add some more, let's say this is plus 50 degrees. This is minus 50 degrees by itself. This would then be plus 10 degrees. Somebody please explain to me where the heck the plus 10 degrees comes from, because your intuition is perfect on this one. So it's 20% of an excess. So you only get 20% of the rotation. What is 20% of positive 50? Positive 10 degrees, not percent, but perfect. Yeah. And good luck finding the degree symbol. If you're on a Mac, I think it's Apple K. I'm curious. No. Oh, option K, I mean, sorry. So that come up as a degree? Yeah, not Apple, option. Copy paste, let's go. Woohoo! Okay, perfect. So 10 degrees. Okay, so good on that, even though I typed 5. I just wanted to check, see if it worked. Okay, let me screw with you one more time, because again, job satisfaction. Let's say somebody said it was a minus 40% EE. That would mean which one is in higher concentration, S or R? S, and by a 40% excess, meaning the difference between the two must be 40%. So they add to 100 and differ by 40, and 40% is not being canceled, 30% cancels 30, 40% excess of this. So 40% of 50 would then be a negative 20 degrees. So does this concept of enantiomeric excess make sense? And then the bigger question, how many have seen this before in your travels through OChem? It's one of those topics that depending on your teacher, they probably threw it towards the end. So we got one never, one I have not, maybe a little, a nope, not really. Yeah, and it's one of those things that I was hoping one of you would say, yes, my teacher was totally into it. Okay, they basically told you and didn't go into much detail. But the reason it's a little more prevalent on the MCAT than it would be in an OChem class, do we ever use reagents such as enzymes, or I guess analogs to enzymes, that help us get one enantiomer over another? Yeah, in OChem, it's not as critical, but basically, if you use a catalyzed reaction or an enzyme controlled reaction, then you can start getting more of one over the other. And so racemic 50-50 and enantiomeric excess, it's honestly not a major concept, but there was about a 1-year stint of time where literally almost every MCAT had a question on it. Why, I don't know. Probably one wild hair that some test writer got and they all copied. So just, it's fair game. So let's go back to this one then. So which of the following statements accurately describes the enantiomeric excess associated with the synthesis that invokes a chiral auxiliary? What is a chiral auxiliary? So I'm going to describe something to you, and you tell me if you've ever heard of this before. You have this massive enzyme, E, and some substrate that binds it. So there's my substrate. And then whatever else comes in can attack from all sides or only one side. So the substrate binds the enzyme, you get this enzyme substrate complex. And therefore, do you agree, whatever it is can only attack from one side or can attack from all sides? Only attack from one side. So in the end, after the enzyme spits it out, you have your enzyme substrate complex breaking down. You now have that compound as your product. And is it 100%, let's say R, for instance? Let's say attack from the right side. Attack from the right side, let's say, gave me R. How many agree you get 100% of this product and none of the one from the other side? Do you believe this? Is this something that you've seen at some point in your biochem travels, that biochem reactions, enzyme catalyzed reactions, are stereospecific? It's a mix of both in OChem, but in biochem, now we have really clean reactions. So in biochem, how many have learned that we get pretty much 99.9% of one enantiomer and very little of the other? Yeah, I mean, how many do remember that from your biochem travels, that you get, because of this enzyme, this massive enzyme holding it in place, it can only be attacked from one side, not both. So you only get one enantiomer. So is that why it's so important that our amino acids are all L? Because by them all being L, does that mean the enzyme is chiral specific and therefore only one product can be formed from that enzyme? So we're very chiral specific. Okay, I am now going to officially mess with you. So now that you are convinced this is true, yeah, in context, it is a beautiful thing, and it makes you realize that OChem and biochem go together really well. But that means I'm going to screw with you. I'm no longer going to call this an enzyme. I'm going to call it something a little bit different. Now I'm going to be an O-chemist instead of a biochemist. How many have ever heard of, in your car, on your stereo, or your home stereo, or some sort of stereo, you have an auxiliary jack? So has anybody ever worked the auxiliary jack on their thing? Auxiliary port? What do you do with it? What do you do with the auxiliary port, auxiliary jack? Plug something in, plug a jack into it, use it for a while, remove it, plug it in, remove it, plug it in, remove it. You read something that's permanently there, or is it an auxiliary, something that can go on, come off, go on and come off? Goes on and comes off. So instead of calling this an enzyme, I'm now an O-chemist going to call it a chiral auxiliary. Chiral auxiliary binds the reactant, so the nucleophile comes on one side, and instead of a substrate, I'm now calling it a reactant. Instead of an enzyme, I'm calling it a chiral auxiliary. Is it the exact same story told by a different bedtime storyteller? So young biochemist children from their parents will hear stories about enzymes doing this. But young OChem children, they hear stories of chiral auxiliaries doing this. It is the exact same thing spoken by two different flavor chemists in their wonderful stories of how these things work. So it goes on, it comes off, it goes on, it comes off. It's an auxiliary. So whether you call it an enzyme in biochem or a chiral auxiliary in OChem, same story. Okay. So as the effectiveness of the auxiliary increases, the enantiomeric excess increases. Would that make sense? As it binds it more tightly and blocks one side more effectively, is that going to make it more and more of the pure enantiomer you need? So how do you rank statement 27? Does that seem believable or non-believable? And I'm asking all of you to step up and answer, even if you don't fully know the terminology. Would you believe that if something is more effective at binding one side, yeah, the more tightly it binds it on one side, the more it's going to block that side and force it to go one side? So that's true. And if you have any doubts, how many double check with the answer choices? How many like, oh, I'm not sure, so let's look at what our answer choices tell me is statement one probably true or false based on how many times it appears in answer choices. Probably true because it's in 3 of them. 3-to-1 ratio or 3 out of 4. So I'm going to go with true. Now I need to look at statement 2. For a product mixture exhibiting an optical rotation of 20 degrees with enantiomer exhibit 40 and 40. So let me go back and change my numbers here so that I can match with the question. So if you look at this later, if you screenshot this, you'll be in a lot better spot. So let's say it's 40 and 40. Then 20% of 40 is 8%. 40% of 40, 4 times 4 is 16. So 16 degrees. And so what they're saying here is when it has an enantiomeric excess of 50, so let's go with 50 in this chart now. So positive 50% EE would be 75% of one, 25% of the other. 50% of 40 degree would be 20. How many are okay with this? So I basically added to the table to make that choice D correct. How many are okay with that? That if you have 20% or 50% excess of something that has 40, 50% of 40 degrees is 20 degrees. How many buy into that? That looks true. So that just made it our best answer. Should I look at C? Not necessary, but because we are students as opposed to test takers this moment in time, false. What's the racemic mixture in enantiomeric excess? There is no excess. It's 50-50. 50 minus 50 is 0. So 0 excess is racemic, not 50. Okay. Is this a tough question? But when you get done doing it, do you feel a little bit better about what you know? Again, is this I got beat up a little bit, but I'm good to go? Okay, definitely. The second most important question is, does this have any relevance to what you could potentially see in a test that had lots of biochem on it? Yes, except it would be called an enzyme. So know the terminology, know how this correlates to biochem. That's definitely important. So number 2, the key thing here is when you have 50% excess, what does that mean exactly? That means that rather than having equal parts where they're balanced, you have an excess of 50%, meaning you have a 75-to-25 ratio. So I have 75% of one, 25 of the other, which means 75 minus 25 is 50%. So I have 50% more R than S. So I have an excess of 50% R that isn't being canceled by S. So if normally pure R is positive 40, if it's only half excess R, so instead of 100% R, it's 50% R, then you only get 50% of what you could get maximum. So maximum is positive 40, as it says here. So 50% of 40 would be 20%, or 20 degrees, excuse me. So that's where that comes from. Does that make sense mathematically? So basically, the observed alpha D equals the EE times the alpha D max. I need to box this because I have once again put too much onto one page. So what you observe is an enantiomeric excess, in this case 50, 75 minus 25, so 50% excess, times the pure 40, 50% of 40 is 20. So yeah, exactly. How many relate to what Stephanie's saying? That you may not know everything in a question. You may not feel 100% confident in the passage, the question. You're going to have that doubt. It's going to happen. You're experiencing all the time. So how many are getting better and better at navigating their anxiety, navigating their stress when going through questions? And it takes time. It is the hardest part of your prep, is learning to do the best you can when you don't fully know everything. Because how many just don't feel good unless you know everything? you can't write a dissertation on it, you're never going to feel quite right. Adapting to not feeling quite right is seriously a major part of preparing for this test. Okay, move onward. I just realized I haven't lied to you yet tonight. Or maybe I have, and I'm just not paying attention. Okay, which of the following compound? Oh, I have? Oh, thank goodness. Well, I lied to you by saying I didn't lie. Oh, kids aren't at the door yet? No, not yet. Oh, you think they are? I haven't had the neighbor kids yet. So what I was trying to say is I'm going to have to dart out for like 2 minutes when they come. So that part was true. So, okay. What does it mean to be optically active? I'm going to say chiral, not meso. So what the heck does meso mean? So if you describe your physical life now as somebody studying for the MCAT, would you tell people meso active or meso inactive? Perfect. You would tell the world meso inactive. Me sits around and studies all the time. Meso inactive. Meso is an optically inactive compound. So if I had something like this, for instance, compound like this, with a mirror plane down the middle, then I might call this, for instance, 1R3S. So this is a R center. H isn't back, but 1, 2, 3 priority. So R, S. Does the R reflect the S? So does one rotate it clockwise, one counterclockwise? So in essence, is it almost like a racemic mixture in the same compound? The two halves are racemic mixtures, so to speak. That's technically not what I should be saying, but is that kind of the same idea? The R on one side cancel out the S on the other. So optically inactive. And by the way, I probably should bring this up. Is anybody bothered what the heck alpha D means? We always say this, and I should technically be putting brackets around it, but I'm being lazy. So alpha D, alpha is the absorbance of D-type light, which means sodium light. It's weird, but it makes some semblance of sense. Does the compound absorb all wavelengths equally, or does it absorb some wavelengths more than others? Some more than others. Perfect. Does a compound rotate light all wavelengths equally, or does it rotate some more than others? Perfect. Some more than others. So in order, so it's just like absorbance, it interacts with different wavelengths of light differently for absorption. It interacts differently with rotation as well. So what this means is I have to pick one specific wavelength. And so D is a really old physics term for light coming out of a sodium lamp, I think 589 nanometers, but it simply means rotation of light with a very specific light frequency, color of light, wavelength of light. So that's what that means. The D is absolutely irrelevant and it has nothing to do with chirality. Dextrorotatory, it happens to be sodium lamp. And it can be really confusing because when we're talking about chirality, D usually means something different, not just as a type of a lamp. Okay. So the question is then, which of these can potentially be meso? How many carbons in bute? In bute? Perfect. So sorry if my tone was really negative and angering to you. What? What? So could this one potentially be meso? Sure. So that I'm going to say nope, because if one is R and one is S, it's going to reflect. Okay, choice B. Choice B, we have a BR on 2, BR there. And I'm being lazy, not drawing anything else. But now, because it's an odd number, pent, would you agree that the chiral center are distributed around the line going through 3? So carbon 2 and 3, check. 2 and 4, with carbon 3 being a mirror, also meso. 2R4S dibromohexane. Is that where we lose the mirror? If I try drawing a mirror here, are they equal? Nope, I'm not reflecting 2 carbons. Cutting through here and reflecting 3 carbons doesn't work. So that one cannot be meso. And then I kind of gave this one away when I did this compound. So I'm going to say this is kind of like D, except 6 carbons instead of 5, and chlorine instead of bromine. But how many okay that same reason got rid of this one here? I'm going to get rid of D. Is this a tough question? How many would say this is tough because it's a challenging topic, or tough because what a lot of work to get through this? Yeah, and that, you just nailed that. It's pretty easy to do any question in the book, no matter how hard it is, when it's totally broken down step by step. It's challenging to figure out those steps. It's actually really, the toughest part is never the material. It's always the connections. Okay, so now second question is brought up. Yeah, polar, little things like that. Exactly. Because meso compounds generally are non-polar because they balance out. Okay, can I erase everything in here because somebody proposed a really good trick? Oh, you can still have it if the mirror cuts through. So here's a case exactly of an odd number 5, where if I have the mirror cutting through 3, 2 reflects 4, or 1 will reflect 5, still can have a mirror plane. So if it's 4, you have a mirror there between 2 and 3. If it's 5, it has cut through 3. If it's 6, it would have had to cut between 3 and 4. So you can, as long as you space it around the mirror. Okay, so here was, do I have to draw it out? So is it okay to clear? 3, 2, 1, get your screenshot in, and gone. Okay, here's the only way you could do this. 4 carbons, 5 carbons, 6 carbons, ring. That's as much drawing as you need to do if you can realize this. Can you have 2 and 2 balanced like that? So in other words, can you balance it out with 2 carbons on one side, 2 on the other, with that one being special, that one being special, 2 and 3? So does that picture make sense? Perfect. Can I, if I have a teeter-totter, I have 3 right there, 2 here, 2 here, and then 1 in the middle. And again, that same dot. So if you can visualize it that way, you're still drawing something out, so to come up with this, but eventually if I can get to the point, 4 means split it in the middle. Because it's an even number, the line has to come right in the middle between the second and third. So if you have 2 and 3, even balanced around the midpoint of 4, you're good. If it's 5 long, the middle has to go through carbon 3, so their space 2 and 4 is spaced around 3. This one you can't do it. So if it's 6 carbons long, where's the middle of something 6? On a carbon, between carbons. Between carbons 3 and 4, so you'd have to space it on 3 and 4. 2 and 5, 1 and 6, you're not doing that. So how many feel confident enough to actually do it that way, instead of drawing it all out, to just figure out your balance? Think of it like a balance beam. Yeah, so exactly. Give it a try. See if this makes sense in an intuitive way. Because would you agree, drawing everything out took way too much time for the MCAT? And part of it is learning how to do certain types of questions a little bit faster. And that's, I mean, because the odds of getting this question on the MCAT, maybe not exactly like this, but knowing whether something's optically active or inactive, definitely something you'll have to deduce. And it's just, I don't know, I think if you start doing it and trying the tricks to make it faster and faster, it'll help in the overall understanding. Okay. Which following compounds does not show optical rotation? So is this the exact opposite? Instead of saying which one is not meso, I'm going to read this as one is asking which one is meso. So let's see if you can do this for me. Exact same thing we just did before. So to be meso, you have to have a mirror plane. So how many carbons in butane? 4. And in hexane? 6. So you would have to have 3 mirroring 4 or 2 mirroring 5, which you don't. So those are out. Oh, shoot, sorry. I don't know, I bumped it. Oh, oh, did you say something wrong and I missed my opportunity to yell at you? Oh, no. Oh, wait, I thought, oh no, I thought I just let somebody in and I hope I didn't launch them into they can't come in. Or at least one of you on Discord to see if somebody is like there saying, why won't he let me in? Why does he hate me? Okay, thank you so much. Yeah, because I hit accept. Did somebody pop in? Did you guys see Monica pop in for just a minute? Oh no, I think I hit accept. Hopefully it was just bad internet connection on her end. Okay, back to this one. Do you agree for this one, it's got to be 2, 3, or 1 and 4? And it is 2 and 3, so that's looking good. So how do I decide between 2R, 3R versus 2R, 3S? Which one is a mirror? Perfect. So that one is your meso compound. So that one can't do anything. Okay. Which compound cannot be, oh, I'm sorry, did you guys get to screenshot it? Sorry to turbo.
Todd, just to double check. So that like 3 and 4, you're saying that's where it would have to be like split down the middle in order to be.
Yes.
Let me say, okay.
Exactly. Because it's 4 carbons long. That means 1 and 2, carbons 1 and 2 on one side of the mirror, 3 and 4 on the other, or carbons 1 and 2 on one side, 3 and 4 on the other, which means 2 and 3 would have to reflect, or 1 and 4 would have to reflect chiral centers.
Got it. Okay, thank you.
Oh, you're welcome. Okay. So which one cannot be optically active? So again, is this a case of asking, is it meso or is it not meso? Cannot be optically active, meso inactive. And how many say that every time? And it's gone from something that's funny to now just sadly so true that it's no longer funny. But yep, meso inactive. Okay, so I'm looking for a meso compound. The difference is, are these linear or cyclo now? So this one's going to be a little bit different. Or achiral. That's going to be the other thing that's kind of funky and weird. So the difference is we have an ol and a chloro. Are those two ever going to reflect one another? No. An OH, a reflection of OH is not going to be, it would be an HO, not a chloro. So in that case, we're actually now fishing for the case of achiral, not meso. Okay, I'm going to draw ring structures, and you tell me if there's any way a 5-membered ring can ever have a mirror plane with 2 different substituents. Cannot. So I'm going to safely say this choice A has to be chiral. Okay. However, if it has 6 carbons, is that a different ballgame? So I'm going to be totally lazy and make this choices B, C, and D. Hopefully you can forgive me for this. For B, I'll put the Cl here. For C, I'll put the Cl there. And for D, I'll put the Cl there. Which one of these can actually have no chiral center? And if you have any doubt, tell me whether this is RS. So if I tried to identify, we had an OH here, an H in back. Do you agree these 2 carbons are equal? So I go one further, these 2 are equal, and then they hit the same carbon. So is this group here the same as this group here? Meaning you don't have 4 unique things on this, same thing here. Cl and H, but these 2 carbons are equal, connected to the same. So same group on each side. So choice D is achiral. No chiral center, no rotation of light. Okay, so perfect. Did I suffer from the, if it's inactive, it must be meso syndrome? Yeah. Hey, that is pretty good. So, a chiropractor. Oh, man. Okay, I like it better that way, honestly. That's pretty good. Stupid chem joke. I got to chalk that one up to you. So I have to, in response, that whole one-upmanship, do you know the IUPAC name? You know what this compound is? Transparent. Transparent. Yep. So that's what you get. Stupid chem jokes. Okay. Moving on. Which compound can form diastereomers? So this one is same concept, but far more general now. To be a diastereomer, what has to be true? You have to have a minimum of how many chiral centers if you're going to be able to form diastereomers? And let me go one step backwards. What exactly are diastereomers? Give me 2 definitions. The formal definitions you get in all your OChem books, and then also a general definition, an intuitive definition. First definition, non-superposable and not mirror images. And then a quicker and easier way. Yeah, not a mirror image is the formal definition. No hand, no mirror. Okay, so non-superposable, not a mirror image, but the other one, all, some, or none of the chiral centers differ for diastereomer. some chiral centers differ. All of them would be enantiomers, perfect. None of them would be identical, some. But it's not just one, it's at least one, but not all. So if you have 7 chiral centers, then it'd be anywhere from 1 to 6 of them different. Just can't be all. So as long as it's not all, then they're diastereomers. So if you have a 1,2 vicinal center, vicinal diol, what is a vicinal diol? So there's carbon 1, there's carbon 2, and there's the rest of the chain. In the vicinity, perfect. A diol, they're 2 OHs, not on the same one. How many chiral centers in this compound? Just one. Why is carbon 1 not a chiral center? Has 2 H's, exactly. Okay. Choice B. Now we have carbon 1, carbon 2, carbon 3, etc. Rest of the chain. How many chiral centers in this one? Perfect, 2 now. So can that one potentially have diastereomers? Yep, because if you only have one, it's either all one of them or none one of them. Can't have some if you only have one, but this one is possible. What is a geminal diol? Perfect timing. Gemini, geminal, they're on the same one. So geminal. So just like twins, perfect. I don't know if this popped up in a lecture before, but how many of you have survived in bio by being able to translate into a Latin-based language from time to time? Has that helped you ever in bio? Definitely. It works a little bit in OChem. OChem has some German, OChem has some Latin, OChem has a bunch. Oh, yeah, and occasionally it helps in cars. I mean, it should help in everything. And I didn't realize that until years later when I realized, when I went from being a primitive speaker, because I went to school in a pretty shitty school district, just truth be told. And it was later on realizing that picking up a second language really helped to become better at a first language, because Latin is everywhere. For what it's worth, like, I don't know how to say it in many languages, but like in Spanish, vecino, neighbors, these are neighbors. Gemelas and gemelos, twins, coming from the same one. So if you happen to know a Latin-based language, and somebody in class gave it in French, somebody in class gave it in Italian, and they sounded very identical, or Gemini and vicinity. Oh, yeah. I mean, isn't it really humbling when you realize this? My first day of grad school at Berkeley was so humbling. And I realized, okay, I was the last person they took because somebody who really belonged here probably said no. And so I was like the whatever. I walked home thinking, okay, I'm the most moronic, worthless person in this school. So I'm gonna have to work twice as hard. Most growth and best work ethic. So yeah, I mean, it's just like I knew I had to bust my butt to catch up to everybody. Said the person who ended up going a totally different path than everybody else. Okay, switching to GChem. Hopefully, I mean, are you feeling a little bit a stereochem out on that one? Which, by the way, never just realized I need to go back because oh my gosh, my screen isn't catching up. There it is, finally. Okay. Oh, no, overshot it. Okay, for this one, I forgot to keep making choices. So busy telling you pointless stories. What is glycerol? And do I really need to know glycerol? Danka? Yep, you do, because is glycerol absolutely essential for understanding triglycerides, the phospholipid bilayer, do all those things bind hydroxyls to make long chains, and therefore the cell membrane, the fatty acids that we store, whatever it is. Is this R or S? So is it D or L glycerol that we use? And I'm feeling proud because this is one of those moments. This is a TGL moment. Todd's gonna lie because glycerol has no chiral center. Are there 4 unique things on that center carbon? No. So this has 2 H's, this has 2 H's. This one has an H and OH, but identical groups. There's no such thing. It's achiral. So therefore, it can't be the right answer to this one. But also, that's an easy thing to mess with you. Oh, I did get you. I'm feeling pretty solid. So somebody in private chat just said, you got us. And trust me, I'm feeling really good. You can't see it because I have my camera off, but I'm doing such a really amazing victory dance right now. So just so you know, I feel good. I have job satisfaction because I've totally screwed with you, and I'm happy. Yeah, if you didn't know the structure, then it'd be a tough gig. This one you know for sure can be. This one is an unknown. Always slant your decision towards the known over the unknown, unless you know it's to be wrong. But I mean, always go with your gut because it's almost always right. Okay. GChem. So let me figure out first off, we're diluting. So we start with 10 milliliters and add 100. So is this a case of M1V1 equals M2V2? Okay, so help me out. What is M1? That's going to help me a bunch. What's my initial concentration? So this is one of those tricky things. So I know pH equals negative log H plus, but also spun backwards, H plus equals 10 to the minus pH. Luckily, this is a whole number, so it plugs in nicely. 10 to the minus 2, exactly. So M1, 10 to the minus 2, or 0.01 to make life easier. V1 is 10 milliliters equals M2, what I'm going to solve for, 100. Is that true? Or have I totally screwed this up? Ah, this is where I made my mistake. What is the new volume? 110. Why 110? You're adding the two together. Shit. Easy to mess that one up. Really, really easy. So, and I hope my string of profanities isn't like too derailing for everything, but sometimes that just sums it up so well. I have no idea what this is, but I will tell you it's less than 0.001. Would you agree with that? Because 1/10 of this would be 0.001, 1/11 is just a hair less. Okay, so if, now I'm gonna like totally mess with this, but if 0.0001 molar H plus, then pH equals 3.0. If less than 0.001 molar H plus, then what is pH? Is now higher or lower? A little less H plus would make the pH go just a hair higher. So we're talking 3.01, 3.02, but something, but given the answer choices, what's the best answer choice, C or D? Just a hair greater. So does that question make sense? Because if you change the volume by 10, the pH changes by 1. If you change it by a little more than 10, it's going to change by a little more than 1. So it's barely more. I mean, we're talking 3.01 or 3.02 is the right answer, somewhere in that ballpark. But is that enough to make D a better answer than C? Okay. Free to move on from this one? Okay. This is one of those where I have to decide, what do I have in solution? Do I have a pure weak acid, a pure weak base, or a mixture? So first thing, identify what we have. Perfect. Mixture of a weak acid and conjugate base. So do I use the acid equation, the base equation, or the acid-base buffer equation? Technically, I should be putting brackets around this because it should be molarity over molarity, but it could also be moles over moles because liters will cancel. So I'm being ambiguous to say, as long as I have the same mole-based units, we're good. We can get this ratio. Okay, before I do anything, can you solve this without actually solving it? Can you intuitively come up with a plan on this one? So here's hoping that you would notice the following. Are the pH and pK differ by exactly 1? Perfect. Is the pH a linear scale or an exponent scale, log scale? It's a log/exponent scale. So log in one direction, exponent the other. So the same rules for logs are the same for exponents. Multiply numbers, you add their exponents. Add logs, you're multiplying the numbers. Okay, so in this case, if it's a difference of the log scale or exponent scale of 1, you agree the real difference then is 10 to 1 or 1 to 10. So because they differ by 1, it's got to be a 10 to 1 or 1 to 10 ratio. And does it favor the acid or the base when the pH is higher? So when the pH is greater than pK, that means it's richer in base or richer in acid. Richer in base. So the ratio of acid to base must be 1 to 10. So just out of curiosity, what was the thing that was the undermining thing on this question? Was it that you got everything right and it was 10 to 1 and they switched it up here? They being me, because I'm the mean evil person who did this. Is that what threw you off? Because you got the 10 to 1, you got the 10 part. So what made this one go off the rails?
For me, I think in my brain just automatically saw that 1 pH difference, and so I knew it was 10 to 1, but because I didn't really know how I got there, I was then just guessing.
No, but see, isn't that beautiful? So you weren't guessing, you totally knew it, but you knew it so intuitively that you couldn't trace your steps, basically.
Yeah, I like ran and then I fell over and then I was like, I don't know where I am.
Oh, yeah, I know that feeling. But yeah, I mean, it's just, you need to be so proud you got the 10 to 1. That is the important thing on this one, to know your pH to pK relationship. And then it's a matter of just deducing it. So in retrospect, would you agree? Not such a bad question. You should be able to get things like this in the future. And from your travels in biochem, did they ever mention the Henderson-Hasselbalch equation? Engeldorf, or whatever H name you want to call it?
Yeah.
Oh, yeah. Knowing this relationship, for whatever reason, biochemists love this maybe this is the only thing they got out of GChem they liked, but it's just so, I mean, so prevalent that hopefully you can tag these. Okay, screenshot if you will. I'm clicking on. This is a damn hard question. So, oh, happy Halloween to you, and hope all goes well. And that big promise that the kids next door were going to come over sometime between 4 and 6, now realizing they must not like us. So, yeah, this question is well, hard to describe what the question is without delving into my vast vocab of profanity. But if you can bear with me, yeah. What, you don't think they like the MCAT prep books? Gosh, it's so funny you say that because, I mean, I don't know if you guys know this, but yeah, we basically shut down all our real classroom centers. And so I was running 3 different centers down here. And now I have a garage full of worthless furniture. Literally, Salvation Army turned down the furniture. And it's good furniture, but they just had too much because basically every business folded. And I have boxes of books that I don't know what the hell to do with at this point. So anyway, I mean, and it's just a weird situation of a whole bunch of office stuff. So if you need a whiteboard, let me know. Although I've given most away. Maybe, but not, I would never do classroom thing again. Okay, how I would do this one. 2 things involved. Do these 2 react with one another? Can HOAC, which, am I actually supposed to recognize what that is? Is that obscure or is that common? I wish I could tell you it's obscure. It's actually shorthand that's supposed to be really common. So Stephanie mentioned it. It's a weak acid. This is the shorthand for acetic acid. God knows what crack-induced chemist decided that you couldn't just write that somehow writing quack was going to help you more. But this is H on an acetate. It's got to be acetic acid. So, yep, that's a common shorthand. Adding it to OH minus, this is a Q, not a G, so is going to go to OAC minus plus water. I'm just going to leave it as is because I'm out of room. So I want you to tell me a few things. Is the concentration going to go down because of dilution? Just based on dilution, you have 20 milliliters and you added 10 milliliters of something else. Is the volume going up? So molarity is going down. So let me just take this educated guess. I have 0.3 molar, and I'm going from 20 milliliters to 30 milliliters. So just instinctively, what is the new concentration if it was just dilution? Just based on the dilution factor alone. 0.20 molar, just based on dilution. Okay. Second thing, are we looking for this compound or this compound? HOAC or OAC minus? OAC minus, okay? So how much of this is turning into this? So this is where your math instincts will kick in. Do you agree they're the same molarity, but half the volume? So half. So of this thing right here, half will be OAC minus, half will be HOAC. What's half of 0.2? Yeah, you create a perfect buffer. Half 0.2 is 0.1. You've got the right answer, but how many just don't feel it? It makes sense. It is intuitively sound. It is a valid way to do it. And if you're really good and you have a strong foundation, that's the way I would recommend. Oh, I copied off Jonathan. So my recommendation, sit next to Jonathan on the MCAT. Jonathan, when and where are you taking it? So, oh, 190th Street. It's Gardena. It's on that side of the 405. It's on your side, not the other side. I thought it, for some reason, I thought it was on the Hawthorne Lawndale side. I'm embarrassed to admit, I don't know where it is. So is it, okay. Is it somewhat near like the refinery? Oh yeah, so it's literally right near the freeway. Okay. Yeah. Oh, okay. So yeah, the track's right near the 405. Okay. I didn't know that. But what I do know is this. Jonathan said that if the volume went from 20 up to 30, molarity probably went from 30 down to 20. M1V1 equals M2V2. So 0.3 times 20 equals 0.2 times 30. Meaning when we took 20 milliliters and added 10 more, so 20 plus 10, we brought the volume up to 30. We brought this down and half of it is there. So are you good with the turbo intuitive, nothing following convention approach? Because I'm going to erase it and do the more formal way. I don't feel good about it morally. Oh, get over it. If you still have morals at this point of your studying, you're not studying enough. You're clearly doing something wrong. So if you still have ethics and morals, stop it. Correct answers. You got it. Okay, I'm going to do the legit way just to have it out there. Okay, the legit way would be this. Icebox. Initially, you have 20 milliliters at 0.3, so you have 6 millimoles of this. Wait, stop, ice, no. Yep, you have 3 millimoles. Please tell me where these numbers come from. I'm just going to leave it milliliters times molar, moles per liter. I'm leaving the milli in there. 20 times 0.3, 3 times 2 is 6. 1 dot there, 1 dot there. So 6, 3. It's going to shift in this direction. You're going to lose 3 and lose 3 because it fully reacts, plus 3. And I don't really care at all. So 3 millimoles, 0 and 3 millimoles of that compound. So the molarity of OAC minus is 3 millimoles of OAC minus over 30 milliliters of solution, because I mixed 20 and 10. So overall, the millis cancel. So how many agree the math method isn't that bad? Oh, yeah, the ice table is still a pain in the butt. What is ice? Ice, baby. Come on. It's a really bad rap song where somebody totally stole from pre-existing songs and ripped off in not only other songs, but an entire culture. You should know this by now. It's a bad 90s rap song. Please don't ask anymore. I'm sorry, that's so wrong. Is there a total generation gap and you have no idea what the hell I'm talking about? Like the biggest thievery in music history was that. Yeah, it's iconic because he completely stole everything, made up the lie about his life, stole from his friends, stole from a culture, stole from Queen and David Bowie, just stole everything. It's pretty awesome. But that said, ICE stands for initial conditions, the change in the reaction, and E for equilibrium. And it's just a nickname they give to how you set this up, icebox. Yeah, so the change in the system. But they just call it the ICE method. So admittedly, took me a long time. I had no idea why people were saying ice to it, but I figured, okay, whatever. But yeah, it has nothing to do with immigration services, has nothing to do with bad rap music. It's initial conditions change in equilibrium. So where did the 6 and 3 come from? The initial amounts, you initially have 20 milliliters of 0.3. So that number right there is 20 milliliters of 0.3 moles per liter of HOAC. Liters cancel, and I'm left with millimoles. And then I move the dot back that way. So 2 times 3 millimoles of HOAC then turns into 6 millimoles. So if you don't mind sharing this, when you say it was on your last MCAT, it was a question where you needed to solve with ice, or they gave you an ice table in the thing and left like some holes in it you had to fill in? Yeah, so as much as I prefer to avoid the ice table if at all possible, we still have to go through it because we have to set it up because for exactly what you just said. And here's the upside and downside. The things I teach, I think, are pretty cool for getting answers quickly, except for one small problem. I don't write the MCAT. And so every now and then there's somebody who's just stuck in their ways of traditional ways of solving things like the icebox that's going to ask you about an icebox. Because I may have, this is totally hypothetical, but once upon a time in a land far away called a previous MCAT, I may have had a question that simply asked, under which of these following circumstances can X be ignored in the icebox? And they didn't say icebox, but in the equilibrium setup. So same sort of story. So can't ignore it here, can't ignore it here because it fully reacts. But anyway. Okay, free to move on from this one? Tough question. Oh yeah. No, because in this, it's always moles or millimoles. So the table. So initially I have 6 millimoles, and then the 3 millimoles here is from 10 times 0.3. Again, move that dot over, move that dot that way, 1 times 3. So we initially are taking 6 millimoles of this plus 3 millimoles of this. Is this compound strong or weak, OH minus? So NaOH is a strong base, exactly, which means it is highly reactive or inert. If it's a strong reagent, highly reactive. So all 3 of them are going to push forward. So when this one goes forward and spends all 3, it's going to eat up 3 of these and form 3 of these. So 3 left over from the original 6, 3 formed from that reaction. So the 3 that are formed, millimoles, divided by 30 milliliters, the new volume, gives me the 30 milliliters in the denominator. Hopefully it seems okay. Yeah, exactly, because all of it will react, exactly. So no more question mark, no more O. It's 3 because capital L will react, exactly. So you meant that as a statement of power, not a question. Sorry to always do that to you guys, but I really want that to just be part of your demeanor. Get confident. Never cocky, but confident about it. Then we come to this one. How many just look at this thing and just go, some profanity, dang. Yeah, yell out the wrong answer. No, yell out the right answer and occasional wrong. You're gonna get a few wrong, that's okay. But what made this one funky weird is instead of a titration curve, is it a titration table? So I want you to tell me what is true about titration curves. How can I tell a strong curve and a weak curve? I don't know, I need your help. Ellipse, which means pH starts out high, levels it out. You could draw it out. I don't want to. I am not going to do it. So weak one has a lip. The strong one has lip or no lip. No lip, which means it stays relatively consistent. Do any of these show a major climb in the beginning? And does one show hardly any climb at all before a rapid climb? In the peach, doesn't change, doesn't change, doesn't change, doesn't change, and suddenly shoots up. I hear a knock at the door, so I'm going to maybe ditch you guys. Do you mind if I peek? I'll be back in just a second, sorry. Okay, I'm back. I'm so sorry about that, but our neighbors are just seriously really cool. We live in one of those spots, so that said, we just ran into that awkward sort of thing because we had special gifts for them, but the kids were taking so long that other kids caught up and they're all like, "We don't get the big cookies." It's like special gifts. No, there's these cool Halloween cookies, like they're just with characters and all that. And so they got to pick. Like, if you ever see Coco, the Pixar movie, it was Coco character, or wait, is it Coco? Yeah, I am. Oh my gosh, why I'm drawing like the movie? It is Coco, right? It's seriously one of the best Pixar movies around. And so it was like the characters in there. And so, because they're Pixar kids, they just seen Coco. But then the other kids were like, "We want those cookies." And so it's like awkward. So I ran away and my poor wife has to deal with it. Okay, back to this then. Weak curve, you said, A is weak. I agree with that. It shoots up at fast and then it stays relatively constant in the middle. This one stays constant in the beginning and then shoots up at the end. And this one climbs in the beginning, stays relatively constant in the middle, and climbs. So how many would agree weak, strong, weak from the numbers? This one was really tough because we're not used to seeing a table, we're used to seeing graphs. And again, you're a test writer. Your goal is to mix things up enough to mess with people. So have I achieved my goal of simulating their meanness by giving a table instead of a graph? Same data, same everything, but does it screw with you? But do you notice it now in retrospect? Yeah, so basically this is 0.73, but notice how it changes from 0.73 to 0.3 to 0.2 something to 0.1 something, 0.18 and so levels off. So it's seeing that difference. Yeah, the identity trends, and that's what you have to do. So do you see it now is a key thing. When you translate from the numbers to a graph, like you said, graph it. So perfect. Okay. Second thing. Okay, so with that in mind, what do I know about a strong curve? Tell me the one thing I know automatically. The 1 point without any question. Equivalence. Perfect. So would you agree that's equivalence? How many agree with that? Which means, is this half equivalence? So is that pKa for A? Is that pKa for B? How many are okay with that information from a completely screwed up, different, never seen this before perspective, but totally true? Equivalence is 7, so 50 is equivalence. So 25 is half. pH equals pK, exactly. So 50 is equivalence and 25 is half. That's pK. That's pK for A, B, and that's strong. Yeah, so why could you do that? If you go back and you look at it, they're all the same molarity to begin with, titrated by the same base. That's why. Yep, exactly. Molarity and volume were the same, exactly. That's the only reason to do that. If that wasn't true, that would not work. But that is right up your alley of doing stuff like that, giving you something where you can compare and you have to be intuitive. Okay, so now let's get back to this question. So we're dealing with acid C. So 50 is equivalence. 25 is half equivalence. So that would mean the following is true. And that is 50 milliliters are equivalents. So 25 is half. So do you agree if I've added less than 25, it's richer in acid? If I've added more than 25, it's rich in base. Is that true? Before, I haven't gotten the halfway point, it's still mostly acid. Afterwards, mostly base. So where does 7 fall? Do you agree 7 is somewhere around here? Can I guess that 7, that point right here, is, I don't know, how many agree 7 is around 13 or 14 milliliters? How many agree with that? That 10 milliliters got me 6.84, 15 got me 7.05. So can I say around 14 would get me to 7? Okay, so is 14 before or after this 25? 14 is before, so you agree we're somewhere around here. So pH is a little bit less than pK, and you have this. So what you end up getting then is 14 A minus formed and 36 parts HA to go. And I'm coming up with this because 50 is what we need total, and I don't feel like converted to anything. So do you agree it's richer in acid than base? So the weak acid exceeds the conjugate base, weak acid exceeds conjugate base, true. I'm going to get rid of these two because it's not true. And then the question comes down to, is 36 to 14 3.59 or 2.53? 2.5-ish, exactly. 36, the amount of weak acid, 14, the amount of base. Do you agree that's less than 3, greater than 2? Best answer then is choice B, as in butt kicker. Oh, no, I didn't just do you. Sorry. Okay. I apologize. Want to get caught up so you can take a screenshot as needed. Okay. So that number then makes choice. My screen has died, so I'm going to have to guess. I'm going to put my pen here. Go with that one, because this is between 2 and 3. So looking at this, how many agree this is a killer passage? This is a killer question. No doubt about it. What have you gained from this? What can you walk away knowing? One, they can mess with the way they present data. You have to be flexible enough to look at things in multiple different ways. It's just, if you're not, it'll take its toll on you. Number two, was it the simple points? So 7 at equivalence, then for that's equivalent, this is half equivalent. So you knew what the pK was, you knew pH is less than pK, so you knew it was richer in acid than base. How many agree this was a test of basic information in a really unfamiliar setting? So the difficulty was not in the content or your knowledge of the content. It was, what the blank are they asking me? For those who've taken the MCAT before, how many felt that on a few questions? Where just, what are they asking me? I just can't figure this out. And that's my goal, is always to try to push that sort of feeling. And so each of these small victories where you learn, okay, I look at it this way, will help you not freak out as much in the future. You'll freak out on 1 or 2 questions in the MCAT, so what? That's not going to be a devastating experience. It's when you overcome freaking out with stuff like this that matters. And hopefully you do that far more than you freak out. Okay, onward we march. I think there was one more submitted. What is the identity of acid B? Now you better get this right. You have 10 seconds or less, go. Stephanie, I see your mic's on, but you're not telling me the answer, dang it. Is that pressuring you? That is my goal. Same stories before. 7. So 50. Strong acid, monoprotic. So diprotic out, diprotic out, weak out, strong in.
Did you say it was monoprotic just because there was only one equivalence point?
Yes, yes, because 7 is the equivalence point when it's strong. If it's diprotic, then this becomes a number less than 7. So sulfuric acid, first equivalence point is actually less than 7 because you have a second proton that can now be acidic. So key thing, because they're both strong, so you get it down to A or B, but a monoprotic gives you this nice, beautiful curve. So this is a monoprotic strong. This is a strong diprotic. And this is the ugliest question mark ever drawn in the world. It's now a little bit prettier question mark.
I guess what's confusing to me is I don't understand how I would have seen like 2 equivalence points in this table. Like, how would I be able to identify that?
Yeah, see, that would be really, really tricky. So if I had a table like that, let me do 0, 50, 100. So I might see 1, 1.1, 1.2, et cetera, all the way up to, let's say, 3.8. And then it would shoot up 4.9, 5.3, 5.4, 5.5. Let's say 6.1, 8.2, 9 point whatever. So you would see close, shoot up, close, shoot up, and level off. Would that be really tough to recognize? Close together, fires up, close together, fires up. Yeah, it would be a bit overwhelming. And I think that is beyond the scope of what they do. It's a great question you proposed, but just like here, nothing, rapid climb. So does that seem all right?
Yeah. Do you have the drawing from the previous slide for just a second, or did that vanish?
No, I can have it in just a second. It's just let my iPad get over its anger and pissed offness at us. So
Sorry, I was like still trying to digest this answer.
Okay.
So I didn't have a chance to ask a question. So I get that the equivalence point is pH of 7, but then pH of 7 for C still at 50 milliliters, not at 14.
But why is that? So somebody want to chime in why? Because I don't have my book around. So somebody mentioned earlier. So why the heck am I saying that that's the same equivalence point as these two? So somebody mentioned it earlier. Actually, it might have been you who mentioned it.
No, yeah, I mentioned it. I'm just like not seeing it on this graph. Like when we turned it into graph form, I got really lost.
Okay, so let's put all three graphs on together on the same page. I'm going to start with B because I think B is the easiest one to see. So B is going to look like this. Ah, my thing moved just to that moment. Ah, shoot. I don't have the thing anchored down where I'm at. Okay, so that's that curve. No big change, then a massive change. No big change, then a massive change. Okay. A, I'm going to do in red. A starts a little bit higher. It climbs in the beginning and then levels off, then shoots up and has the same endpoint here, or the same over titration, but that's greater than 7. And that ends up being 4.26, because again, we have the exact same molarity needed in that exact same volume. So we're good on this one. And then this one, again, we're starting a little bit higher. And the same sort of thing, it all sort of blends together. And this one is, let me get my X in the right spot so it matches. Got 7.44. So are these three graphs matching what we saw here? Is A climbing, leveling, and climbing, climbing, leveling in the middle, climbing. This one's flat in the beginning, check, and then climbing at the end, check. This one's climbing and levels, and then climbs again.
Oh, I see it now. Yeah, so then when your pH is 7, it's going to be just before that halfway equivalence point.
Yeah, exactly. And then that's a point we're fishing for. So would you agree it's so much easier because this is familiar, even though it's the exact same information?
Yeah, drawing it out definitely helps.
Yep. So now then I ask you, do you know everything that we just went over? Yes.
Yeah.
Was it unfamiliar and screw with you? Yeah. Getting used to dealing with the unfamiliar is essential for this test. And I don't know about you, but in everything I've ever done MCAT wise, every single time there was at least 1 or 2 passages on each section that just freaked me out, that I had to literally calm myself down and say, okay, it's going to be fine. And the test went well, meaning calming down helps. So, and I honestly think that's the secret, is not letting anxiety get the better of you. Easy said, hard to do. And how many would find that? Anybody who's taking the MCAT, how many would agree? Sometimes you just have to stop. Yeah, you just have to catch your breath, massage your fingers, and say, what the blank. And I'm telling you, profanity is my saving grace, because once I just let it out, like, screw it. F-bomb it, and I feel better. I don't encourage you to F-bomb things, but I mean, whatever it may be to calm yourself down, detox from time to time. Okay, do you need to screenshot this before I click on? 3, 2, 1. Okay, I lied. Now 3, 2, 1. So this one, and then we're switching back to OChem. But now you guys get to tell me everything about this. So probably should know the reaction first off. So the reaction in this passage dealt with this compound here, which they had some Diels-Alder, they got some 6-membered ring, and then they added an epoxide to it. And here's the key thing. So, did Stephanie just crash? Okay, I'll see if she bounces back in. But luckily, this wasn't her question. Or basically, she just said, "Screw it, I'm done. I'm going to go trick or treat. I'm getting some of those cookies. Damn it, I like cocoa." Okay, these two centers are formed from a previous reaction. It's cis addition, but they say you isolate this compound and you treat it with this. This is a nucleophile. This nucleophile is going to attack that carbon, but in theory, can it attack from either top or bottom? Can it come in below or above? Either one. Which means the new chiral center you get here could be top or bottom, which means if it comes from on bottom, this gets pushed top. If it comes in from top, it gets pushed down. So it ends up, does this chiral center also end up being variable? So in the end, I have 4 chiral centers in the final hydrolysis product. sp2 not chiral, sp2 not chiral, CH2, CH2 is nothing, CH3, CH3 nothing. But these two and these two. 2 of them are locked and 2 of them can vary. So out of the 4 chiral centers, how many can differ? 2 out of 4 can differ. If some, but not all, 2, but not all 4 can differ, does that describe enantiomers or diastereomers? Diastereomers. It's not meso because there's no mirror plane. It's not enantiomer, it's got to be diastereomers. So now the question is, with diastereomers, are diastereomers, when you have 2 of them, do they cancel one another? Or is that only enantiomers that cancel? So when they say racemic, do they say any old mixture, or do they always say of enantiomers? They always say enantiomers. If you have diastereomers, it's going to be optically active. So best answer is C. Is this a tough question? This is kind of a butt kicker. And I mean, no doubt about it. But it makes sense once you see it. And I hope that's what all this is. Once you see an answer, it clicks and makes sense. Oh, okay. What this means is optically inactive. Optically active, meaning doesn't rotate light, does rotate light.
Wait, Todd, I have a question really fast.
Yeah.
Could you have canceled B and D right away just from, because like
yes.
The definition of it was wrong?
Yes.
Okay.
Yeah. So I mean, not to say I'm angry at you, but I'm angry because you totally stole my thunder because I'm going to say, by the way, this cool trick, you got it. So perfect. So actually, it's awesome. Get rid of things that just can't be true. Diastereomers have optical activity. Meso doesn't. So meso has to be inactive, not active. Diastereomer has to be active, not inactive. So exactly, you could have gotten rid of those 2 straight away. So good job. Actually, very impressed. So for this one, how do I solve this? I don't know how to do these, so you got to teach me something. Find number of chiral centers. Perfect. Chiral centers and then 2 to the end. Perfect. Chiral centers come in 3 flavors. 1, quaternary carbons. Quaternary carbons in this, would you agree, are here and here. And there's a CH3, the 5-member ring, the tertiary in that side, the ring fusion here, this one by itself, the ring fusion here with a double bond. So those 2 are chiral. Then there's also tertiary chiral. So tertiary would be this intersection of the ring, this intersection of the ring, that. So here it has 1, 2, 3 R groups and an H, 1, 2, 3 R groups and an H, 1, 2, 3 R groups and an H. Just make sure everything else, CH2, sp2 doesn't count, sp doesn't count, CH2, 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 CH2. What about this one right here? Could this also be a chiral center? Perfect. Secondary with the substituent. Carbon here, H in back, OH in front. So altogether, 1, 2, 3, 4, 5. 2 to the 5th equals what? Or 2 to the, can't count. 1, 2, 3, 4, 5, 6. Oh, yep. That's embarrassing. What is 2 to the 6th? Even though it says it right here. So I'm going to put this thing so you can't read it. Oh no, diversion. I'll make you stare at this so you don't see it. But yeah, 2 to the 6th. 2 times 2 times 2 times 2 times 2, 2. How many like me have to do exponential expansion that same way? 2, 4, 6, or 2, 4, 8, 16, 32, 64, count up. So perfect. Best answer. B is in. Boy, I think I got that one. Okay, screenshot is necessary. Clicking on in 3, 2, 1. And we're on. Oh yeah, and only one of them, only one of those 64 actually does what you need biologically. The other ones won't fit into an active site. So add that to your screwiness in your mind being blown about how amazing. The fact that we're alive is seriously just amazing. Yep, that's where they're specific. Okay, so compounds most likely formed. In this one, you have to know something about the passage, but the reality is this. We went from no chiral centers to 2 chiral centers. So an acetal has an OR and an OR prime of some sort, 1 chiral center. An aldehyde, no chiral centers. An ester, no chiral centers. But an epoxide has 2 chiral centers. So what do you think if we have 2 chiral centers here, we had to go through something with 1 chiral center, no chiral centers, 2, or none? So an epoxide is like a really ring-strained version of a carbonyl. So when you have a carbonyl, you agree a nucleophile attacks here. When you have an epoxide, you still have 1 unit of saturation, but instead of the bond being to 1 carbon, is it now shared across 2 carbons? And you still have a nucleophile that can come in and attack and get similar behavior of a carbonyl. So basically, is it just a carbonyl that wants to explode? I mean, do you buy that that's basically what you're dealing with? An exploding carbonyl, a highly unstable ring-strained carbonyl that says, I'm going to blow up if you don't deal with me immediately. But the key thing, this was a chiral center question. So it's interesting because epoxide formation isn't fair game on the MCAT, but epoxide chirality and hydration and so forth is totally fair game. That's been on there before. And so this one is just focusing on that chirality aspect. That's how this would be a fair MCAT question. Okay. So for this compound, you pass through the epoxide. This was actually shown in, oh, maybe I'm off by one, never mind. The other one is where this showed is the intermediate. This is one that's the epoxide you're getting, that remember ring there? So 2 chiral centers. Hopefully seems okay. Oh, and then, oh, this person's not here. And this is kind of, oh yeah, the previous one, best answer was in fact, I'm so sorry. Yeah, 2 chiral centers. So 1, 0, 2, and 1. You know, 2, so you go with the 1, 2 chiral centers. Yeah, but I think this is so freaking random that we're finishing right on the dot. Okay, that we're finishing 3 minutes early. That's just crazy, but I don't think Stephanie's coming back. I think maybe she checked out. She's gonna be knocking on my door for asking that cookie soon. So anyway, I hope this worked well. I hope, luckily we got everybody who showed up questions answered. And oh, you're so welcome. And it is helpful. I honestly think this is more useful than lecture after a while. I mean, going over questions and seeing how they're done is what you need. Learning how to take the test is so much more important. But do you agree it takes a while to realize that, to actually accept that learning how to take the test and getting the information as you go by exposure is actually a better route than trying to get exposure first and then try to learn the test? No. So I have found that, in being as brutally honest as I can, I wrote the book based on that 1 out of 5 or 6 passage that just is an ass kicker. And on the MCAT, yeah, there are some really tough OChem passages, but there are also some that are so unbelievably easy that it's a waste of time to even study for them. OChem seems to be on the extreme ends, and I have definitely written the book. So I will tell you, yeah, the hardest one on the MCAT is comparable to the hardest one in the book. So I'm going to say that nothing in the book is beyond what you could see on the MCAT, but the majority of the book is beyond what you likely will see on the MCAT. Does that answer make sense? That it's on par with the hardest, but it's highly unlikely, unless you are mean to children and just are an evil person and karma catches up, that you'll get something that bad. So just be nice to people, and you might get one weird OChem question. But every now and then there's one from hell. And that same thing with true in physics in GChem. But most of the time, you got to figure out how it ties into biology. If you can't make the connection of biology, and it's definitely true for OChem, pretty true for physics, pretty true for GChem. Anyway, well, I'm on Halloween duty, so I'm going to check out. Thank you guys as always, and I'll see hopefully tomorrow. I know, have a great weekend. Good luck on trick-or-treating. If you don't get candy, let me know, and let me know where I need to send it. Yeah, tomorrow is 4 to 6. Yeah. So have a great night. Okay. Oh, yeah, 4 to 5 plus. You're absolutely right. It is 5 plus. My mistake. Like, I'd say it, but yeah, we'll be going 2 hours every time pretty much. Okay. Have an awesome night, and I will see you hop skip in about 21 hours.